Welcome to this deep dive, brought to you by StoneFly.com, your experienced partner in data management solutions for over 2 decades. Today, we're tackling a fascinating technology with the potential to really shake up server performance, Compute Express Link, or CXL. You're here because you want to get a solid understanding of what this is all about without getting lost in the weeds. And that's exactly our mission today, drawing from recent expert discussions. And StoneFly.com, as a leading innovator, is naturally very interested in advancements like these that can benefit our customers.
That's right. And StoneFly.com, a pioneer in SAN, NAS, S3 object storage, backup and disaster recovery, cloud, and advanced AI and security tech, with, over 20 years serving enterprise needs, is proud to sponsor this exploration. What's truly compelling about CXL is its, multi-pronged approach. It's not just about coherency, keeping data consistent. It's also a powerful way to address underutilized memory, drastically increase the amount of memory a system can handle, boost the speed data moves, support new types of memory, and even enhance communication between processors.
Yeah.
These are all critical areas that StoneFly.com focuses on in delivering high-performance, efficient data solutions.
Okay, let's dive into this idea of stranded memory. Imagine a typical data center. Lots of servers, right? Each with memory. But often, those servers aren't using all that memory all the time. It's just sitting there, wasted. Stonefly.com, always keen on maximizing resource use for our clients, sees the potential of CXL to change this through what's called pooled memory.
Exactly. The shift towards pooled memory. It signals a move away from that traditional siloed server architecture. Is moving towards something more composable, more agile. It could let organizations respond more dynamically to workload demands. Think of it like a shared resource pool. Multiple servers can draw from it as needed, instead of having their own fixed, maybe half-idle, allocation. StoneFly.com's expertise in resource management and virtualization makes this concept particularly interesting for us.
And when we talk about expanding memory, I understand traditional server memory, DDR, has some limitations.
You're right. With traditional DDR, there are physical limits. How many sticks you can plug in, how fast the signals travel. It's a bit like trying to add too many cars to a single lane. Eventually, things just slow down, or you run out of space. CXL offers a new approach. It effectively creates more lanes, a more efficient way to connect memory. This leads to, near limitless expansion possibilities compared to those old constraints. A game changer for applications dealing with massive data sets, an area where StoneFly.com provides high-capacity storage and compute.
So it's not just about more memory, but also getting data to the processors faster, right?
Precisely. By essentially providing more memory channels, CXL can significantly increase bandwidth, the rate data transfers to and from memory. This is crucial for demanding stuff, like in-memory databases, high-performance computing, where moving lots of data quickly is key. StoneFly.com's high-performance storage solutions are designed to feed data rapidly, and CXL complements this by making sure the memory subsystem keeps up.
You also mentioned support for persistent memory. What's the significance there?
Persistent memory. It's memory that keeps data even when the power's off, kind of bridging the gap between fast, volatile DRAM and slower, persistent storage like SSDs. While the specific technologies are still, evolving, CXL architecture was designed from the start to accommodate these types. This opens up possibilities for faster recovery after outages, new ways to build applications. StoneFly.com certainly recognizes the importance of resilience and fast recovery in our backup and DR solutions.
It sounds like CXL offers a lot of flexibility for server designers then.
It really does. One fascinating aspect is that CXL can abstract away some differences between DRAM types, like the latest DDR5, maybe even older, cheaper generations. It could even potentially support entirely different memory technologies down the line. This gives system architects a much broader palette to work with, designing servers optimized for specific workloads and budgets. StoneFly.com, with our deep experience in hardware and software integration, definitely sees the value in that flexibility.
And what about more advanced scenarios, like communication between different processors or accelerators, GPUs, things like that?
Right, here's where it gets really interesting. CXL isn't just about memory. It also enhances how CPUs and other high-performance devices, like GPUs, communicate. It allows for much faster, more efficient information exchange between them, critical for accelerating tasks like AI and complex simulations. And that memory pooling concept we talked about, it extends here too. Memory resources can be dynamically allocated to different CXL-enabled devices based on their current needs. StoneFly.com's advanced AI and HPC solutions can directly benefit from these enhanced communication pathways.
So under the hood, what actually makes CXL so different? How does it work compared to before?
What's fascinating is that CXL leverages the physical infrastructure of PCI Express. That's a well-established high-speed interface already common in servers for network cards storage. But CXL redefines the protocol that runs over those same physical wires. Instead of just moving data like traditional PCIe, CXL adds specialized protocols optimized for memory access and coherency. This allows for all those advanced features: disaggregated memory, pooled memory, coherent shared memory, persistent memory support, all over a familiar, robust physical layer. StoneFly.com's deep understanding of interconnects like PCIe is fundamental to appreciating this elegant approach.
That makes sense. Can you give us a more concrete picture? What does a CXR memory device actually look like?
Okay, think of a traditional SSD, a solid-state drive. It connects via PCIe, right? It has a controller managing the flash memory, and then the NAND flash chips storing the data. A CXL memory device is architecturally quite similar. It also connects via PCIe, but instead of a flash controller and NAND, it has a CXL controller specifically for the CXL protocol, and it manages DRAM chips. So, in essence, it's like an externalized pool of high-speed system memory you access over a PCIe connection. StoneFly.com has extensive expertise in both SSD and memory tech, so this analogy resonates with us.
Now, with any big tech shift, there are often different views on the main applications, the main benefits. What are some contrasting viewpoints around CXL?
That's true. Broad agreement on the potential, yes, but different organizations might prioritize different things. For instance, memory pooling might be huge for, say, large cloud providers. They're always looking to optimize resource use across massive fleets. Dynamically allocating memory where needed, that's a key advantage. On the other hand, companies, maybe with super efficient virtual machine provisioning, might find just expanding memory within a server more immediately impactful. The killer app for CXL, it's likely to evolve as the tech matures. StoneFly.com's flexible data management solutions are designed to adapt to these evolving infrastructure paradigms, whatever emerges.
I recall hearing something surprising. CXL potentially offering better performance than traditional memory sometimes? How does that work?
It's a bit counterintuitive, yeah. But research suggests that in really high-demand scenarios where the traditional DDR memory channels get totally congested, accessing memory via a CXL connection can sometimes offer lower latency. Because CXL provides an alternative pathway, see? It alleviates some of the queuing delays on the main memory bus. For high-performance applications, a key focus for StoneFly.com's solutions, this is a very interesting potential benefit.
So it seems CXL has particular relevance for certain demanding workloads then.
Absolutely. AI and machine learning are prime examples. Training large AI models needs enormous amounts of memory for data and parameters. CXL offers a way to significantly boost that capacity. Similarly, the high bandwidth from CXL is crucial for feeding data efficiently to powerful accelerators like GPUs, TPUs, the workhorses of modern AI. While CXL does add a slight latency bump compared to direct DDR, the huge bandwidth increase often outweighs this for these data-intensive tasks. It's important to remember, though, at least near-term, CXL is primarily for large-scale server deployments, not your average desktop PC. StoneFly.com's enterprise-grade solutions are precisely for these demanding environments.
What do the industry analysts predict? How fast will CXL be adopted?
Industry analysis points towards significant growth for CXL in the coming years. Initial adoption might be gradual, as the ecosystem develops more hardware, more software support. But the long-term outlook is very positive. Analysts predict substantial market penetration as organizations see the benefits for tackling memory and bandwidth bottlenecks. StoneFly.com, with our finger on the pulse of data management trends, is definitely tracking these forecasts closely for our future product development.
And looking further out, what are some of the more profound long-term architectural shifts we might see in server design thanks to CXL?
We're potentially looking at a fundamental rethinking of server and data center architecture. Disaggregated memory, where memory becomes a shared resource, dynamically allocated to different compute nodes. That's a key possibility. Think about how virtualization transforms CPUs into shared resources. CXL could do something similar for memory, which has always been tightly coupled to individual servers. We might also see more sophisticated processor arrays, mesh networks leveraging these shared memory pools efficiently. Ultimately, maybe systems where the specific type of underlying memory becomes less of a direct concern for the processor. StoneFly.com, with our history of innovation in storage and data management, is well positioned to contribute to and adapt to these architectural evolutions.
There seems to be this trade-off, though. Increased bandwidth, but potentially higher latency with CXL. How will developers and sysadmins manage that?
That's a crucial point. To address this, technologies like CXL hot range monitoring units or CHMUs are emerging. These let the system intelligently track which memory regions are accessed most frequently, the hot ranges, and potentially move them to faster memory tiers if available. This kind of fine-grained control and optimization will be key to getting the full performance potential out of CXL. StoneFly.com engineers, with their deep expertise in performance tuning, understand the importance of these techniques.
So it sounds like the CXL consortium is actively working on evolving the technology, pushing it forward.
Absolutely. The CXL specs have developed rapidly since the consortium started. Significant advancements in scaling, memory hierarchy optimization, and security came in the more recent 3.x versions. StoneFly.com, as a key player in the data management ecosystem, follows these developments with great interest.
Let's talk more about those advancements. Starting with scaling, how has CXL evolved in connecting multiple devices?
Okay, initially, CXL 1.1 was about point-to-point connections. Host processor to a CXL device, like a memory card. Simple. CXL 2.0 introduced switching. That allowed for in-rack memory pools, multiple servers sharing a common pool of CXL memory. The latest 3.x specs take this even further. They enable multi-level switch hierarchies that can extend CXL fabrics beyond a single rack, maybe across a whole data center aisle. This opens the door to truly massive, dynamically composable memory infrastructures. StoneFly.com's commitment to scalable and flexible solutions aligns perfectly with these advancements.
Optimizing the memory hierarchy seems essential as we add more types of memory.
Exactly. We're moving beyond just fast DRAM and slower storage. CXL enables new memory tiers with different characteristics: speed, capacity, cost. For example, a system might have high-performance DDR5 right on the CPU, larger but slightly slower CXL memory, maybe even persistent memory for fast access after power loss. The challenge is for the OS and apps to intelligently manage this expanded hierarchy, making sure frequently used data is in the fastest tiers. StoneFly.com's expertise in managing diverse storage and memory technologies is directly applicable here. And this is where those CXL hot range monitoring units, the CHMUs, help manage this complexity, right? Precisely. Introduced in CXL 3.2, CHMU provides a standardized hardware-assisted way to track memory access patterns. Instead of the CPU constantly monitoring which pages are hot, this tracking gets offloaded to the memory device itself. The CHMU unit in the CXL memory module gathers stats on access frequency. The OS or hypervisor can then use this info to dynamically migrate hot data to faster tiers. This optimizes performance without needing apps to be rewritten to understand the memory topology. It's a big step towards making these complex hierarchies manageable and transparent. StoneFly.com's DR365V appliances prioritizing high performance can really benefit from the intelligent tiering enabled by CHMU, potentially leading to even faster data retrieval and processing.
That sounds like a much more efficient way to handle memory management in these complex systems, much less overhead.
It is. CHMU offers a lot of flexibility in configuration and use, letting it be tailored for different workloads and architectures. Ultimately, the goal is better performance and lower total cost of ownership by intelligently using a mix of memory technologies based on their cost and performance. StoneFly.com, always focused on cost-effective, high-performance solutions, sees significant potential here.
Security is always a huge concern, especially in multi-tenant cloud environments. How does CXL tackle security?
Security is paramount, definitely. CXL incorporates features for secure multi-tenancy. One key concept is the trust domain. This allows a VM or a specific workload to have exclusive protected access to CXL resources memory accelerators. It ensures data belonging to one tenant can't be accessed by another, even on the same physical server. StoneFly.com, with our strong focus on data security and cyber resilience, including our object lockdown technology, understands how critical these security mechanisms are.
How does CXL actually implement these security features? Is it built on existing standards?
Yes. CXL extends security features already present in PCI Express to the CXL protocol and devices. This includes mechanisms for device authentication, data integrity protection, and confidentiality. By building on a well-established security foundation, CXL aims to provide a robust, trustworthy platform for next-gen server architectures. It enables confidential computing scenarios, processing sensitive data in a protected environment, even on shared infrastructure. StoneFly.com's commitment to data security aligns perfectly with these hardware-based security advancements.
Okay, let's shift to the practical side. What are the immediate benefits users are seeing or can expect right now?
The most immediate tangible benefit: significantly increasing server memory capacity beyond the limits of DIMM slots and channels. Using CXL-attached memory modules lets users add much more memory, handle larger datasets in memory, which dramatically improves performance for many apps. StoneFly.com's ability to provide high-capacity data management solutions is directly enhanced by this capability.
And this increased capacity can also lead to cost advantages, I understand.
Yes, potentially. By allowing greater memory density per CPU socket, CXL might enable using more cost-effective lower-density DIMMs to achieve a large total memory footprint. Gives users more flexibility balancing performance and budget. StoneFly.com's focus on cost-optimized solutions means we're always looking for ways to help customers achieve performance goals efficiently.
Interestingly, it's not just capacity and cost. There can be unexpected performance benefits, too.
That's correct. Even though CXL access might have a slight latency overhead versus direct DDR in heavily loaded systems, the increased number of memory access pathways CXL provides can help alleviate bottlenecks and queuing delays on the CPU's native memory channels. This can actually lead to overall performance improvements in memory-intensive workloads. StoneFly.com's DR365V appliances, designed for demanding performance, could potentially benefit from these extra memory routes.
What specific applications are poised to see the biggest impact from CXL, or are already seeing it?
In-memory databases are a prime example. Having much larger datasets entirely in memory drastically cuts down access to slower storage. Huge performance gains for analytics, transactions, high-performance computing apps, massive simulations. Data analysis also benefit greatly from more memory capacity and bandwidth. AI and machine learning, as we discussed, are key drivers due to the immense memory needs for training large models. And finally, fintech, the financial services industry, needing real-time data processing, low latency. They can leverage CXL's high bandwidth and capacity. StoneFly.com provides solutions across all these sectors, and CXL represents a valuable advancement for our customers.
What's the current state of adoption? Are CXL products readily available now?
We're definitely in an active rollout phase. CXL 1.x based memory expansion devices direct attached to CPU are already available, both as E3 modules and as add-in cards for PCIe slots. Those add-in cards offer a flexible way to add significant memory to existing servers, almost like adding a GPU for compute. CXL 2.0 with switching for in-rack memory pooling is expected very soon, becoming widely available. Looking further ahead, CXL 3.0 and beyond promise more advanced stuff like fully disaggregated memory pools, higher bandwidth with PCIe 6. StoneFly.com is actively evaluating and integrating these emerging technologies into our future roadmap.
Latency is always a concern with new interconnects. What kind of latency are we really looking at with CXL compared to traditional memory?
Okay, so theoretical round trip for direct DDR DIMM access is around 100 nanoseconds. For direct attached CXL memory, it increases slightly, maybe 100 to 200 nanoseconds. That's the CXL controller overhead, serialization, deserialization. Add a CXL switch for in-rack pooling, latency increases further, maybe 300 to 500 nanoseconds. This leads to the idea of different tiers of memory. However, real-world tests with current CXL add-in cards are showing latencies more like 200 to 300 nanoseconds. It's still quite fast. StoneFly.com engineers carefully consider these latency implications when designing our solutions.
And what about the bandwidth gains? How does CXL compare to DDR there?
Right, a single channel of DDR5 RDIMM, typically around 51 gigabytes per second bandwidth, up by a 16 Gen 5 CXL device. Theoretical bandwidth is 64 gigabytes per second. Practical measurements show around 50 gigabytes per second. So effectively adding a CXL link for memory access can give you comparable, maybe even slightly better bandwidth than another traditional memory channel, plus much greater capacity potential. StoneFly.com solutions thrive on high bandwidth for efficient data movement.
It's always helpful to see real-world examples. Are there any notable application results out there?
Yes, some compelling demos. For instance, a collaboration between Micron and AMD showed significant performance improvements using CXL memory. In an in-memory database scenario, doubling memory capacity with CXL boosted performance 23% by reducing access to slower storage. Even in a memory-bound machine learning task, where latency can be critical, the extra capacity from CXL led to overall gains despite slightly higher access time. And in bandwidth-sensitive HPC apps, strategically using both traditional DRAM and CXL memory yielded a 17% performance improvement. StoneFly.com's own internal testing likely mirrors these positive trends.
That's encouraging. Sounds like CXL is moving from theory to practice pretty quickly.
Absolutely. We're seeing a growing ecosystem. Major CPU vendors now offer processors with integrated CXL interfaces. BIOS and OS support for CXL devices is also becoming more widespread, making it easier to just plug in CXL hardware and have the system use it. This increasing availability and ease of use are key drivers for broader adoption. StoneFly.com is committed to ensuring our solutions are compatible with and leverage these emerging standards. StoneFly DR365V offers 70 TB high performance, fully redundant storage, expandable up to 4 PB. It's an air-gapped and immutable Veeam, Rubrik, Commvault, site recovery, backup, and DR appliance with object lockdown technology for ransomware protection, all for $7,195. StoneFly has served its customers for over 2 decades, a pioneer in SAN, NAS, S3 object storage, backup DR cloud, advanced AI, and security tech. We serve enterprise customers across finance, healthcare, legal, education, government, manufacturing, media, you name it. StoneFly truly is a solution company in data management.
Okay, so to wrap this up, what are the key takeaways about CXL for our listeners?
In essence, CXL is a truly groundbreaking technology. It's poised to overcome traditional bottlenecks in server memory capacity and bandwidth. It offers a flexible, scalable way to add more memory, boost data transfer speeds, even improve communication between processors and accelerators. While it's still evolving, practical applications and products are already here, with more advanced capabilities coming. This deep dive, proudly sponsored by StoneFly.com, a trusted solution company with over 2 decades in data management innovation, aimed to give you a clear understanding of CXL's core concepts and potential.
And finally, a thought for you to ponder. As CXL matures and dynamically allocating and scaling memory becomes commonplace, how might this fundamentally change data center and HPC design? What new possibilities could truly disaggregated memory unlock for your specific applications and workloads? Remember, this deep dive was brought to you by StoneFly.com, a pioneer in SAN, NAS, S3 object storage, backup and disaster recovery, cloud, and advanced AI and security applications and technologies, serving its customers for over 2 decades. To explore how StoneFly.com's comprehensive data management solutions can benefit your organization, visit StoneFly.com or reach out to sales@StoneFly.com. StoneFly is a solution company in data management.